Inductors are key parts in electronic circuits. They have inductance, which is different from resistance. A regular multimeter can measure resistance easily, but inductance is harder. A normal multimeter is useful, but it can't measure inductance directly. Inductance is shown by L and measured in henries or H. You can find this online, but a multimeter has no L or H setting, so it can't do this measurement. Special tools exist for this. This inductance meter made with an Arduino was built to help, but even good projects have problems. Here, a close look shows a broken wire, probably from my bad soldering since this was made a year ago. So time for an upgrade. This time it'll have a built-in battery, a nice big OLED screen for a clear display, and most importantly, several different reference capacitors that I can select. This will give me much better resolution across different inductance ranges. To make this happen, I turned to JLCPCB. JLCPCB provides easy, affordable, and reliable PCB and PCBA solutions, empowering electronics engineers to develop projects efficiently. Order PCBs from JLCPCB effortlessly. Upload your Gerber file to get instant quote and order in minutes. It's as easy as online shopping. Get 1 to 8 layer PCBs for just $2. Efficient large-scale production, reducing costs and bringing you unbeatable prices. Quality and lead time is reliable. All in-house production, ensuring quality stability and strict quality control in every process. Rapid turnaround, lightning fast PCB production in just 24 hours. Easy to use, affordable to make, and reliable to trust. You can always count on JLCPCB. Get $30 off with a coupon and enjoy top quality 6-layer PCBs for just $5. Plus 2 micron e-neg finish and no engineering fees for via InPad. Using the board I got from JLCPCB, this OLED screen fits perfectly. Look at that clean board. The quality is really impressive. Now let's flip it over and see how the 18650 battery sits in its holder nice and snug. And now, it's time to get soldering. The PCB is done, with all of its components soldered. I admire the final results, just what you expect with JLCPCB. Let's take a closer look at this finished board. Here at the front, we have the inductance meter logo and the power button. Around back, we've got the inductance meter logo, version 2. And a little shout out to my groupmates. Hi everyone, thanks for supporting this project. Here's the brains of the operation, the ESP32 microcontroller. I went with the version without the built-in PCB antenna for this design. These are the 2 reference capacitors, crucial for accurate measurements. We've got a 5 microfarad and 100 nanofarad, both from Vishay. This little guy here is an Omron relay. It's responsible for switching between those 2 reference capacitors, giving us different measurement ranges. And over here, we have the programming header. This is how I interface with the board using my UART programmer to upload the code. Finally, this whole section is the charging and power regulation circuit. It takes Type-C input and it has its own battery management system, plus a fast charge IC for the lithium battery. The power button wakes up the device, and we see the inductance meter logo appear. This is the main user interface. You can see the measured inductance value, the frequency, the battery level, and the currently selected reference capacitor, along with the measurement mode. The measurement mode can be either single or continuous. These capacitive touchpads on the PCB allow us to change the settings. I can switch between single and continuous measurement modes, and I can also select different reference capacitors. In single mode, if I try to measure without an inductor connected, I get a please retry message. This device also includes a BNC connector. This allows us to use BNC accessories, such as this BNC2 alligator clip cable. This makes it easy to connect and measure different types of inductors. So, let's measure an inductor. This one is rated for approximately 41 to 46 microhenries. I'll select the 5 microfarad reference capacitor, which is suitable for microhenry measurements, and set it to single mode. Single mode takes multiple measurements for improved accuracy. Of course, we can also switch to continuous mode for faster looping measurements. Alternatively, for surface mount inductors, we can use this SMD pad directly on the PCB. If you're interested in building your own, all the project details including the Arduino code, schematics, and the PCB design files are available on my GitHub repository. You can find the link in the video description below. If you found this video helpful or interesting, please consider subscribing to my channel and giving this video a like. Your support encourages me to create and share more useful and fun electronics projects like this one. Thanks for watching.